Now, here's this wonderful formula we talked about the other day. We look at the population mean and the sample mean, dealing with U and X bar there for those. And so we want to be able to tell what's going on from those. All right, so here we have our classes and then we have our frequencies. Now, the first thing that we're going to want to do is we do need to find the midpoints of these things. Okay? So that's going to be the very first thing. So we go back, we find the midpoint here, and then we're going to look at our frequency. Now, we're not going to worry about doing all of the table stuff. We're going to go back to the calculator to make that work for us. Okay, so let's do that. Go ahead and get your calculators out if you don't have them. Now, our process overall is going to remain the same. The only difference this time is we need to use two columns. Our midpoint needs to go into L1. Our frequency needs to go into L2. Okay? So, again, your midpoint goes into L1. Your frequency goes into L2. So we're going to go into our stat here. We're going to do number 1 to edit. And again, I'm going to go ahead and clear my list, even though it looks like I could probably write over it. But it just makes it easier by hitting clear and enter on that L1. And I'm going to put in just the midpoints into L1. I may not be able to do that very well, but you may just try some other numbers. And then again in L2, we're going to put our frequency for those. Once we get all of that in there, we're going to do just what we did last time. We're going to go back into stat, we're going to move over to calc, and select that one bar. Now don't go any further than that, just get to that one screen. So we're going to hit stat, arrow over to calc, and then number 1. All right, now does anybody's screen look differently than mine? Good, okay. So that means I don't have to worry about writing it down. If anybody's does, if it went just straight to where it just says 1 bars, it does not have this on here, please see me, because we do have to do something different on there in order to capture the L1 and L2, okay? But if yours looks like mine, that's good. Our list is going to stay L1, but we put in a frequency digit, and we put that into L2. So let's go down to frequency there. Frequency list, and you get to L2, you'll see in the background here on number 2, the blue. It says L2, which means hit the blue button, and then hit number 2, and L2 will pop into that frequency list. Second, number 2 for L2, enter. So now I have my list, my frequency, and it will calculate. Now, for this, we will find that our average, our mean, is 182.5. I'm sure once I click through all of these things, we should get to this place. There it is, 182.5. Okay? Questions there? That's the difference when we have it groups. We have to put stuff into L1 and L2. Now, if it's those classes, then you need to find that midpoint as well for those. Okay? Now it also gives us everything else, just like before. We can go down, find our median, we can find our standard deviation, all of those things from this, just the same. Okay? So we still have that available to us. Questions there? Alright, now weighted mean is essentially the same thing. We're giving a weight to those pieces, or a frequency from them, okay? So here is one of those types of problems. It says that this girl, Marissa, is in college. She has an A in a 4-hour statistics course, a B in a 3-hour, an A in her 3-hour psychology. So all these different things going on, and they want to find their GPA. Okay? So we need to think through a few of those things. It does matter. So it says that we had an A in a, what was the first one? 4-hour course. So grade and then hours. Okay? What's the next one? A B in a 3-hour course. A in a 3-hour course. C in a 5-hour course. And A in a 1-hour course. Okay? Now it's per credit hour when we do these things. So our hours is going to be our frequency here. But what is it about the grade? Can we put A, B, C into our list and calculate something? We cannot. What number stands for A in GPA? Y'all remember?
Average?
Actually, a 4. You get 4 points for an A, 3 points for a B, 4 for an A, 2 points for a C, and 4 points there. 1 point for a D, 0 points for an F. So when your GPA is being calculated, that's the numbers they use. 0 to 4 on them. Okay, so anybody has a 4.0, they all A's. Alright, so that's how we do it. And so that is our point scale for those hour classes. Alright, so we can go back then and do them. It says there, yeah. So you can see again, this is the weight on the bottom. So that's the frequency. And so their average, if we were to go put that in our list, would be 3.19. So they've got a little over the average in their courses. That's not too bad. Questions there for that. So again, this would be your L1, this would be your L2. You would do the exact same thing. Questions there? Finding standard deviation, they do the formula, we go right here for those. Again, we have to look, is this a sample or a population for those? So here, I believe they use it as, yeah, so they use the sample here for theirs, because we're looking at a sample of these things in our survey, for 100% population. So since they use the sample, they use S, and they as well got 54.163. It's in dollars, and so I would say actually 54.16 for those. Okay. Questions there? And calculator is important. Here they're doing the same thing on the calculator, showing exactly what we have on our screen as well. All right, questions about the weighting? Now the hardest part sometimes on the weighting will be picking out which one goes into L1, which one goes into L2. And so that's kind of thinking about some of those pieces. I remember one problem was like we had these snacks or like peanuts and almonds and things like that at a cost, and we're buying 3 pounds of it. So my cost would be L1, my pounds is how many of that. So that's my frequency. So sometimes you got to read a little deep and then go, okay, which one is which, so that I put them in the right places for those. And so that may be more of a difficulty than just typing it in for those. Okay, so you may want to look at that a little closer. All right, questions on any of that? All right, next part is 3.4. We look at measures of precision and overall outliers. So let's get into those things. So the first thing we want to look at is called z-scores. A z-score represents the distance from the mean in standard deviations. So it's how many standard deviations am I from the mean, right, for those. And so it gives us some relativity there on that. They are very similar to each other. One is just dealing with populations, one is dealing with samples for those. But they're all still the same thing. It is our data point minus the mean divided by, should be the standard deviation on that. So on this formula, if you print that out, this should have the sigma there. So change that. I've still yet to go fix it. One of these days I will actually fix that in that slide. But that's pretty good after class. Okay. So that population one, let me just write that down again. For that, the population, it should say x minus mu over sigma. So it's the standard deviation. Okay. All right. So here in this example that's talking about the Boston Red Sox versus the Los Angeles Dodgers. The Red Sox scored 876 runs, and they played in the American League, where they have an average of 731.2 and deviation of 72.6, because each league is a little different on how they approach the game. The Dodgers were 804, but their mean for their league was 710.8, and their standard deviation was 60.2. So again, a lot of information, but you won't be able to see those pieces. So if we want to look at their z-score, the Red Sox, we took their number minus the mean, all divided by this piece. Okay? Now, when you're putting that in the calculator, you can do it one of two ways. Many people's calculator will actually do a fraction bar for you that may be helpful for you. Okay, so let's just look at how to do that real quick. Some of them pop up, but if you hit the alpha y equals, you'll see this immediately pop up, right? If that first one right there is a fraction, if you just select number one, a fraction bar will pop in there, and you can auto-populate it and make it look exactly the way that we have it over there. So now I would put on top of the 876 minus 731.2, arrow down, and 72.6, and that way you don't have to worry about it. Did I divide the right things? That looks exactly like my problem now. Okay? Now again, to get to that, alpha y equals, we want to get to that F1 right there. Is what we're trying to do. And then we just press enter, and we get that 1.9. Okay? Now, if you do not do it that way, what you will need to do is you need to put that top in parentheses. That there, 731.2, and then get your divided 72.6. If you don't either do it the way I did on the calculator, or if you don't put it here, it divides those two things and subtracts it from 876. And so then you wouldn't get a very big number, you'd get the wrong number. Okay, so it's important that you put it in correctly. Questions about just putting it in? Okay, just make sure we know those little calculator details. All right, so then the Dodgers came up with a 1.55. And so we can actually use those numbers to compare. Because the Red Sox number is higher, 1.99 is bigger than 1.55, that means they actually produce more runs than the Dodgers, okay? Because it's further away. They are at a bigger percentage there on those. Okay, so the bigger the number, then the better, actually, in this case. All right, the next thing is called percentiles. Percentile, the K percentile is data value that is less than or equal to the percent. Now, ladies will know these as you get older a little bit better, as you choose to have children. Because the first thing they're going to say when you have your kid is their height and weight are in whatever percentile. Okay? So, like my daughter has gotten up to a decent amount of weight, but her height is like in the 90th percentile because she's really tall. Okay? So she, like at 18 months, she was like a 3-year-old size. So she's really tall because I'm tall. All right? So she was in the 90th percentile. That means she's taller than 90% of the kids her age. All right? For those. And that happens. Other kids will be really small. Or like when she was born, when she was premature, she was in like the 10th percentile in weight. So only 10% were less than her. She was a real skinny baby. Don't worry about So she caught up on that. I think she was around the 50th percentile when she was at her 2 years. Those pieces. And so we kind of break it down. We got to be careful how we're looking at it. All of our percentiles are always that number and less. So the P99 means you're greater than 99% of the other data values for that grouping. Okay? But we do talk about it the opposite. You hear this in grades, graduating, they're in the top 10% of their class, means that they're actually above the 90% of the other students. That's what the top 10%, right, was. And y'all had a problem in your previous homeworks where it did that with the OJIVE. Remember, some of y'all getting mad at me because what's the top 10 of this? Or above is these percentile pieces here. Okay. Alright, and so they also do this when it comes to SAT scoring or GRE scoring, so those major college exams. They will say that you have to have a certain score, you're in this percentile. They don't care if you got them all right or not. They want to know how you are compared to everybody else. So everybody knows that you're the smartest dumb kid, right? Or the dumbest smart kid. Either one of them have for those pieces. So here they had that Jennifer scored 600 on the SAT. I don't know if that's good anymore because it's been a long time since I've seen those scores. But in this case, they say that she's in the 74th percentile. So that means her score is above 74% of the other people that took that test when she took it. Okay? All right, the next thing is called quartiles. So we like to look at good round numbers. The 50% mark, the 75% mark, the 25% mark for those. And so you always have your largest and smallest values. Your Q1 is your first quartile. That means you're at the 25% mark. You're above 25% of the other students. Your quartile 2, or Q2, is actually your median. That's the middle. You're at the 50% mark. You're greater than 50% of the other students, or whatever we're talking about. Q3 is the 75th percentile, and we don't have the Q4. We just have the largest value. Okay. Now, we can also look at them backwards. Let's see, did I get a chart there? For those, so I said 75 percentile, all those things, but we can do it as the top 25%, all of those things. All right, so finding those things. Now, they give a method for finding those, all right? But we'll just use the information that we already have. I don't really care about this stuff that's on here because I don't want to type a bunch. I'm going to go back into stat. I'm going to look back at our list. L1, and 5. Okay. If we arrow down on our list, what do you notice? Last things. Q1. Median is Q2. Q3. We have our smallest and we have our largest values. All right there. So our L1 list, that 1 bars, will still get us those same things. We just have to put in the data. I just went ahead and used the previous data so I didn't have to type it all in again. But for theirs, you would take all of these numbers right here, put them into L1, do your 1 bars, because there's not a frequency is there. We don't have to worry about L2. We delete that off. But you get your Q1, Q2, Q3 right here in our 1 bars. So that's a lot of stuff it gives. Again, it gives your mean, gives your standard deviations, gives your median, Q1, Q3, all of those things are listed in that 1 bar. So it's very important for you. Questions about
So
that?
I just like this one. The whole number.
No, standard deviation is how much it deviates from the mean. So what one standard deviation would be. So in this case, my standard deviation is 50, so it has a super big
I
curve.
changed it. I swear to God, I kept doing it like 3 times. It kept saying, there's no this for the new range. And it was
Alright, so they go through, all their stuff's gonna be different because I have different numbers in here. It's too easy to do. So I put those all in. Eventually they do the same thing. Alright, now the next thing is the interquartile range. The interquartile range is the middle 50%. Typically where a lot of our stuff is grouped. What's the middle 50% of our group? Well, that is from the Q3 to the Q1. So to find our interquartile range, our IQR, we're going to do Q3 minus Q1. So for my information, I would do 212.5 minus 137.5 for mine. Okay? And that's going to give us my IQR, because it's just a range. And that just tells me all of that is going to be within so many points of each other. Okay? So they do that from our example earlier as well. Now they're using the car stuff from earlier. So 339, 33. They just simply subtracted Q3 minus Q1. Still looking at distribution. We don't need that here. All right, checking for outliers. Now, if y'all remember, outliers are things that are like really different, okay, from our group. So in here, if we had somebody in here that was 100 years old, they would be an outlier in our age group, right? Because that's not very common. It can happen, not common for those. And so we want to be able to see if things are outliers, all right? Or if we have like a 12-year-old, and we're in college, we don't have 12-year-olds in college. We can. Right. Now to do it, the first thing we need to do is find our first and third quartiles and do the interquartile range, the IQR. Then we're going to determine what's called the fences. This is our cutoff points for what we consider as normal. Okay? Now here's the formula for that. All these things are formulas, so we'll write them down and come back to it later in your PowerPoints. But your lower fence is going to be your Q1 minus 1.5 times your IQR. It's always 1.5. Okay? But it's Q1 minus 1.5 times the IQR. Your upper fence, so the upper side will be your Q3 plus 1.5 times your IQR. Okay? So if we have a value less than this number, it's an outlier. If we have a value greater than this number, it's an outlier. Anything between those two numbers, we're good. Those are normal and would be acceptable in our ranges. Okay? All right, so let's go back here. So back on their table, they had Q1 at 735, Q3 at 4668. They determined their IQR, 3933. And so for their lower fence, we have Q1 minus 1.5 times that 933. And they come up with a negative 5,000. So if they had anybody that was less than negative 5,000, which there was nobody on that table that in a negative at all for those, then that would be an outlier. The upper fence, plug it in, Q3 plus 1.5 times IQR, they come up with 10,567. So if anything on that table is bigger than 10,567, $567.50, that's an outlier. It is unusual to the group. And they see there was one at 21,000. So that is unusual. That's an outlier for those. Okay? And that's going to change some of our things that aren't around all the rest of our information. Questions there? All right, well, that gets us through those two. We'll have one more section, chapter 3 next time. And we'll look more into those as well. Pieces, but, if you don't have any questions, then it's you can work on your homework, or I will see y'all next time.
Look at mine, look at yours. It's different.